We will be discussing about amalgam. Amalgam, this term is generally used in our day-to-day life. Like we say dental amalgam. When you have filling in the teeth, then you say it's a dental amalgam in film. So amalgam is basically it's a homogeneous mixture of a metal with mercury. For example, we have sodium amalgam, then the metal sodium is being amalgamated with mercury. Okay, and it is prepared according to use where you have to use the particular amalgam. Okay. So basically, amalgam is a type of mixture in which metal is present with mercury. Okay. Now, if we see some example, we can see the sodium amalgam. It's written like this: symbol of sodium and the symbol of mercury. It is shown by a dash, then it is denoting sodium amalgam. Okay, it is used to decrease the chemical reactivity of sodium metal. Okay, and so it is also said to be a good reducing agent. So it is used where we have to have a reducing agent. So sodium amalgam is used as reducing agent. Second, we see tin amalgam. SNNG. It is used for silvering cheap mirrors. Okay. Now this second I talked about dental amalgam. It is an amalgam of dental amalgam is amalgam of silver. It is highly unreactive. So it is filled in the tooth cavity where there is a cavity in the teeth. Amalgam of silver is filled and it is unreactive. So whatever you eat, or it will not get deteriorated. It will not get removed. So these are few amalgam. Now even amalgam is used for the purification of. You can say it's helping in the extraction of native metals like gold and silver. So there is also necessary for making amalgam. Okay? They are used for, I can say, amalgam. That is the process of making amalgam. No? Amalgamation is used for extraction of native metals. Native metals that are silver and gold because they are found in their native state in nature. Okay. So from the native metal ores, these are used for their extraction. Okay. So this was about amalgam. It's just a short interest note. The next thing, the next thing we are going to discuss in metals is about its chemical reactivity. We have studied, we have seen the reactivity of different metals, so we can know how they can get easily affected by the atmosphere. Okay, that is by nature around them. So we can call that term as corrosion, and we'll be studying about corrosion. What is corrosion? Corrosion. Okay, basically it is that process by which a metal when exposed to atmosphere it is attacked and it loses its properties. Okay, that is it comes in contact with the air environment and forms undesirable compound on their surface. Okay? That is they are not remaining as they are originally. This is what its corrosion means. So you can say corrosion is a process of. Basically, corrosion is the deterioration of a metal. Okay? It is the process by which a metal gets corroded. So, if I have to define corrosion, I'll say it is a process Now, if we have to see some examples, we can easily see around us the examples. The most common example is the formation of rust on iron. When you see an iron rod, the original iron rod, which is only consisting of iron, it is seen that there is a brown flaky substance present on it. Okay, when it comes in contact with the atmosphere, its color is like it's having a coating of brownish substance, and that is rust, which is formed because of the corrosion of the iron. Okay, so that is another phenomena known as rusting. So basically, it is also corrosion. It's corrosion of iron, and then it is known as rusting. Similarly, other metals also corrode. We'll see some examples, then we'll come to know easily. Corrosion of iron. This is termed as rusting. Now, iron, it gets corroded. That is, there is a formation of brown substance, as I said, yellow brown substance. So, but it is corroded in the presence of oxygen, and there should be moisture in air. Then only iron will get corroded, and it will form hydrated ferric. So there is necessary of oxygen and moisture. First, what happens is iron combines with oxygen, and there is formation of an oxide. That oxide combines with the atmospheric moisture and forms hydrated ferric oxide. So this compound which is formed is known as hydrated ferric oxide. Basically, this is the reaction of rusting which is involved. Now, how did we come to the conclusion that oxygen and water should be necessary? For this, we will conduct a simple experiment which will show us how rusting occurs and what are the necessary conditions for rusting. Okay. I took three test tubes. These are all covered. They are closed with a tight cork. Test tube A, test tube B, and test tube C. I put oil in this test tube, water in this test tube B, and in the next I keep some other substance, that is calcium chloride. Okay. So in this A test tube I am having oil. Here water is present, and in the third test tube it is calcium chloride. Okay. Now what I do is I place an iron nail in it, all the three test tubes. Now, as in the first test tube, the iron nail is completely immersed in the oil, and so it will not get rusted. It does not rust. The conclusion we came to know that iron nail in A does not rust, whereas an iron nail in B, there is formation of a yellow orange compound on the iron. So we can say that there is formation of rust on the iron. And in third test tube, I had put calcium chloride. Now calcium chloride, it absorbs moisture from the air, and here oxygen is present, but the moisture has been absorbed by calcium chloride, and when the test tube is closed, we see that rusting does not take place. So this shows that in the first case, both neither air nor the water was present, because it is not coming in direct contact with it. So only oil is there, and so there rusting is not taking place. In the second case, we see oxygen and water both are there, and in the third case, only oxygen is there, water is not there. That time also no rust is found. So this is just a simple experiment to show the conditions required for rusting. So the necessary conditions for rusting are presence of oxygen and presence of moisture. Without this, the rusting does not occur. Okay. Now, as iron is mostly used at many places, many machinery parts and many buildings, so it's very important for us to prevent it from rusting because atmosphere contains oxygen and moisture. So there should be some measures for the prevention of rusting. Okay. So how can we prevent rusting? We'll take few methods by which rusting can be prevented. So prevention first is by painting the iron. For example, the railings in your house, you see it is being painted black by black paint, or you see it's being painted mostly. Nevertheless, you don't see an iron railing as such. Okay, and if it is kept as such, then you will find that there is a deposition of rust. So we can prevent it by painting with paints and varnishes. Secondly, we can prevent rusting by coating the metal, that is iron, with another metal. Okay, so if I coat iron is coated with metal like zinc, and this coating of zinc on iron is known as galvanization. So I can say that iron is galvanized, means it is being coated with zinc. Okay. So iron is coated by metal like zinc and it helps in preventing rusting. How? When iron is coated with zinc, then zinc will be reacting with the atmosphere and iron will remain safe. Now, zinc oxide, if it is formed, then what will happen? It will form a covering over it and it will not allow the metal to react any more further. So you can see that it is helping iron to prevent from rusting. Okay. You can also use metal like tin. Tin is also used to coat iron and prevent rusting. The next method by which we can prevent rusting is by alloying. By alloying is means that pure iron gets rusted, but if it alloys are made of iron and then used, then the rusting can be prevented. So iron is alloyed with chromium and nickel, and therefore rusting can be prevented. Okay. So these are a few ways by which we can prevent rusting. Now this was the corrosion of iron. Now we'll see the corrosion of aluminium. Metals like aluminium, they also corrode. And sometimes corrosion is useful. We see that if aluminium is used, then what happens? A layer of its oxide is formed, and when it comes in contact with the atmosphere, and this layer of oxide helps further for the metal to be less corroded. It means that the oxide formed, that is the oxide Al2O3 will be formed, and this oxide will act as a barrier in further corrosion. Okay. So sometimes corrosion is helpful. Once a layer is formed of this oxide, then further corrosion will not take place. Whereas in the case of iron, what we see that the hydrated ferric oxide which is formed, the hydrated part, water vapor, in the form of water vapor, it goes away and the rust is formed and that falls down as the brown um, I can say brown powder or in the form of dust. Okay. But in the case of aluminium, what happens? This aluminium oxide which is formed, it is very unreactive and it provides a thick layer. So the further aluminium will not corrode, and in this way corrosion of aluminium is useful. Okay, because it will prevent the further corrosion of the metal. Another example we'll see, that is corrosion of copper. These are the common metals which we used in our daily life. Now copper also gets corroded. We'll see some, if you see the copper utensils after some years of what happens that there is a little layer, you can see the greenish layer is there on the copper metal. The actual color of copper is lost, and that is also because it's coming in contact with the atmosphere. What happens here is the carbon dioxide and water vapor from air, they combine with copper and they form carbonates and hydroxides, and in this way the basic carbonate copper is formed. What is basic copper carbonate? It is actually Cu Cu3 dot CuOH the whole 2. Okay, this is basic copper carbonate, and it is formed due to the action of surrounding on copper. As copper's reactivity is very low, so this rust the copper carbonate is not formed very fast as in the case of rust. Iron is very reactive and rust is formed, although it's a slow process, but it's comparatively faster than the formation of copper carbonate. So copper carbonate forms basic copper carbonate as its corroded part. Okay, so in this way we can see the corrosion of silver also. Silver also corrodes. You see silver after few months or few years, the silver it gets little a blackish in color. Now, why this happens? Although we say silver is less reactive and it will not react easily, but what happens here is in the atmosphere there is presence of H2S gas, that is hydrogen sulfide. This hydrogen sulfide, it reacts with silver and it produces silver sulfide. Okay, and it will produce this is silver sulfide. Again, here silver sulfide is formed, and this silver sulfide it has black color, and that's why we see the silver ornaments after few years. They have a little blackish appearance when they are in contact with atmosphere. Okay, so these are the few metals and how they corrode. What are the products on corrosion?